Okay, in this video, I want to look at these two problems. So the first one, straightforward, find the general solution to the following system. Okay, so the matrix is 1, minus 1, 1, minus 1. Then it's going to be 1, 3, 5, 3. And then in the bottom, it's 3, 2, 8, 9. Okay, so we're going to row reduce. So I'm first going to subtract row 1 from row 2 and 3 times row 1 from row 3. So the top row stays the same. 1 minus 1, 1 minus 1, 1 minus 1 is 0. Okay, 3 minus minus 1, that's 4. 5 minus 1 is 4. 3 minus minus 1 is 4. Okay, 3 minus 3 times 1 is 0. Okay, 2 minus 3 times minus 1. That's the same as 2 plus 3, so that's 5. 8 minus 3, so 8 minus 3 times 1, that's 5. Okay, and 9 minus 3 times minus 1, that's 9 plus 3, so this is going to be 12. Let me make sure that's right. 9 minus 3, so that's 9. Okay, that's 12. Now the next thing I'm going to do is to divide the second row by 4, so I'm just going to change all of these to 1s. Okay, and now I'm going to subtract 5 times row 2 from row 3. So this is 1, minus 1, 1, minus 1, 0, 1, 1, 1, 0 minus 5 times 0 is 0. 5 minus 5 times 1 is 0. 5 minus 5 times 1 is 0. 12 minus 5 is 7. Okay, now I'm going to divide the third row by 1, or sorry, by 7. So this is now a 1. Okay, and now I'm just going to save room, I'm just going to do the following. I'm going to subtract row 3 from row 2 and row 1. So all this is just going to change that. Or I'm going to subtract row 3 from row 2 and add row 3 to row 1. Okay, and now it's almost in row echelon form. Now I just want to add row 2 to row 1. So minus 1 plus 1 is 0. And now this entry 1 plus 1 is 2. Okay, so this is now in row echelon form or reduced row echelon form. X1 and X2 are the pivot columns. And so this means that X3 and X4 are the free variables. So we're going to solve everything in terms of X3 and X4. So X1 is equal to minus 2X3. X2 is equal to, oh, sorry, X4 is not, what am I saying here? X4 is not a free variable. Okay, so the pivots are the first column, that's a pivot column, the second column, and the last column. Okay, the bottom equation says X4 is equal to 0. The top equation says X1 is equal to minus 2X3. The middle equation says X2 is equal to minus X3, and then X3 is equal to free, so we'll call it T. So the general solution is X1, X2, X3, X4 equals minus 2, minus 1, 1, 0 times T. Okay, so every solution to this equation is given by a vector of that form, T times that. Okay, and for example, you can check, like if you say T is equal to 1, this is going to be minus 2 plus 1. So minus 2 plus 1 is minus 1, plus 1 is 0. And then the second one, it's going to be minus 2 minus 3, that's minus 5, plus 5, that's equal to 0. And then minus 6 minus 2, that's minus 8, plus 8, that's equal to 0. Okay, so that's question number 9. So now let's answer question number 10. So notice that the system in question number 10 is the same, at least the left-hand side of the system in question number 10 is the same as in question number 9. So we want to find the general solution to this system. And notice that the general solution is going to be given by a particular solution to the non-homogeneous equation plus the general solution to the corresponding homogeneous equation. Okay, the general solution to the corresponding homogeneous equation is that one. Okay, VP, now we have to solve this equation to come up with a particular solution. Okay, but observe, so let me just point out, if we actually were to solve this equation and find a particular solution, then we basically would not be able to use this work up here, because whatever method we did to find a particular solution to this equation, probably it's just going to give us the general solution. Okay, in other words, if you row reduce the appropriate matrix here, you're just going to get the general solution. Okay, so the idea is to use this piece of information that I've given you, plus the thing that you already did above to answer this problem. Okay, so what we have here, the piece of information that I've given you is that 0, minus 4, minus 12 can be written as a linear combination of this vector in that way. Okay, so it's 1 times 1, 1, 3, plus 1 times minus 1, 3, 2, so on and so forth. Well, notice that these vectors are the columns of this matrix here. So in other words, a particular solution is going to be 1, 1, minus 1, 1. So if x1 is equal to 1, x2 is equal to 1, x3 is equal to minus 1, and x4 is equal to minus 1, that is a particular solution to this non-homogeneous equation. Okay, so then this right here, this is one of the theorems in the book, I think theorem 2.36, tells us that the general solution, so this is a particular solution. This is a particular solution by the given fact. So the general solution is V equals VP plus the general homogeneous solution. VP is 1, 1, minus 1, minus 1, plus the general homogeneous solution, or the general solution to the corresponding homogeneous equation, plus T times minus 2, 1, 1, 0. Okay. And so this is the general solution to the equation, to the system of equations in problem number 10. And again, we're using this fact here that the general solution is equal to a particular solution plus the general solution to the homogeneous equation.